So welcome to this first set of video lectures for the 2WN50 course Introduction to Computational Science. So this is the first set of a list of about 6 sets of video lectures, and within each one of those playlists, let's say, we will cover a chapter of the textbook that is used in this course. The textbook that we use is this textbook Numerical Methods for Engineers and Scientists by Amos Gilad and Vish Subramaniam. So by following these video lectures, I will elaborate on the main parts of the course material and give somewhat of my personal insights and my personal views on these things, which will serve as kind of a guideline in studying the material on yourself for the remainder of the course. Before we start, let's dive a bit into the details on the background knowledge that is assumed from each of you for this course. And that is that we do assume a certain level of mathematical background knowledge, which roughly corresponds to having taken your first course in calculus and having some notions on linear algebra. For instance, things that we really assume that you know are the continuity of function, what that means, differentiation and integration, so what derivatives and integrals are, and being able to calculate those for relatively simple analytical functions. Linear systems and matrices, and how to solve such linear systems for small systems by hand. Also ordinary differential equations, which should be part of your calculus course that you all should have taken by now. So ordinary differential equations or ODEs, and being able to solve simple linear ODEs by hand. Also, the notion of Taylor series of functions in one variable is something which will definitely come in handy for deriving many of the numerical methods that we will see within this course. Now, if there are certain gaps in your mathematical background knowledge, then that's not an issue per se. But then I strongly recommend that you study chapter 2 of the handbook on mathematical background in significant detail. So in addition to your mathematical background knowledge, I also assume that you're able to do some basic programming for this course. Because it's kind of a hands-on course, we will not only focus on the theory, but also really want to apply the theory in practice. So for that, we need some basic programming skills, and the scientific toolkit that will be used within this course is MATLAB. For that, we have arranged that there is a MATLAB tutorial available on Canvas, which I strongly recommend that you follow. And in addition to that, you can look into Appendix A of the textbook again, which also introduces, well, let's say the main concepts that are relevant for following the use of MATLAB in the video lectures, but also in the practical assignments for your homeworks. Let's take a look at the course material that we'll be treating within 2WN50. So we won't be covering the book entirely, but we'll go into some selected topics. So first off, the content of this set of video lectures is the introduction, where we will basically set the scene, give some context, what is scientific computing, what are possible issues that can arise. Before we move on to solving nonlinear equations, so nonlinear equations which you typically cannot solve by hand, but we will be able to solve them numerically using computers. This will be followed by solving systems of linear equations. So in the prerequisite knowledge, I already mentioned that you should be able to solve simple and small systems of linear equations. Well, in chapter 4, we will learn how to solve very large systems of linear equations with the use of a computer, which would be completely infeasible to solve by hand. Then we'll skip some chapters and take kind of a shift of focus, and we will look into how to calculate derivatives and integrals of functions, not on paper, but using a computer. So that's numerical differentiation and numerical integration in chapters 8 and 9. We will close off the course with, let's say, the most advanced topic, but also maybe the most interesting one from my point of view, and that is on ordinary differential equations. How can we solve ordinary differential equations, which typically there are no analytical or tractable solutions to solve these by hand? How can we solve them using computers? And we will focus on initial value problems. So from an initial condition, how do we solve the dynamic behavior of a system which is governed by an ordinary differential equation? So as already mentioned today, in this set of lectures, we will look into the introduction. Now, this introductory chapter consists of 4 main sections, where first a background is given to put the things into context within this chapter, and this is done for all of the subsequent chapters in the handbook as well. Followed by following comes the representation of numbers on a computer. So, and we will see that there is a very specific way in which we can represent numbers in a computer, and that this also holds certain implications and limitations as to how we should interpret numerical solutions in practice. We'll also go into what kind of errors that can occur in numerical solutions, so round-off errors, truncation errors, and how these influence, let's say, the accuracy and fidelity of numerical solutions. And then we'll close off this chapter with a short part on the use of computers and programming for solving mathematical problems.